It may seem counterintuitive to use a barometer, a sensor designed to measure atmospheric pressure for weather forecasting or altitude, in a robotic hand. However, in the context of tactile sensing, the barometer acts as a highly sensitive, durable, and cost-effective tactile sensor, touch sensor. Rather than measuring the weather outside, it measures the weather inside the robot's fingertip. 1. How it works, the internal weather concept. In robotic hand applications, the barometer is not exposed to the open air. Instead, it is embedded inside a sealed, flexible cavity within the robot's fingertip, the skin. The setup, a tiny MEMS, microelectromechanical systems, barometer chip is placed on a circuit board inside the finger. The finger is then covered with a soft, rubber-like material, elastomer, that seals air or a fluid around the sensor. The contact. When the robot's finger touches an object, the soft skin deforms and compresses. The measurement. This deformation reduces the volume of the sealed cavity, causing the air pressure inside to spike. The barometer detects this minute change in absolute pressure instantly. 2. Why use a barometer instead of standard pressure sensors? Researchers, such as those behind tactile sensing solutions, a related technology, favor this approach for several engineering reasons. Extreme sensitivity. Consumer barometers, like those in smartphones, are sensitive enough to detect an altitude change of just a few centimeters. In a robotic finger, this translates to detecting micronewtons of force, allowing the robot to feel a feather-light touch, approximate 5 millinewtons, comparable to human sensitivity. Durability. Traditional tactile sensors often use fragile wires or capacitive plates on the surface of the finger, which wear out quickly. In the barometer method, the delicate electronics are safely protected deep inside the finger, with only the cheap, replaceable rubber skin exposed to the world. Slip detection. The high-speed data from these sensors allows the robot to detect high-frequency vibrations. If an object starts to slide from the robot's grasp, it creates a specific vibration pattern, shear force, that the barometer hears as rapid pressure fluctuations, allowing the hand to tighten its grip automatically. 3. Application in robotic hands explicitly utilizes this technology to achieve general-purpose dexterity. Blind manipulation. Because the touch sensitivity is so high, the robot does not need to stare at its hands to know it is holding something. It can feel the object's presence, shape, and hardness. Dynamic range. The sensor can handle the delicate task of picking up an egg without crushing it, while still being robust enough to handle heavy tools.